us talk about better data labeling with EMBLEM and how that impact defect prediction from the RACE lab, which is real-time AI for SE. My name is Hui or Ken2, along with Dr. Menzies from North Carolina State University and Dr. Joju from RIT. So let's start with, why do we care about labeling quality? Is it a good research practice? And Gray et al. Noted that defect prediction results utilizing public domain fault data repository have been obtained without any scrutiny of the data. The naive assumption of these inexperienced researchers are that the open source data, such as those hosted by NASA and Promises, have reasonable quality for data mining tasks. Among 209 relevant papers for the systematic literature reviewed by Hall et al., data quality is an issue in many studies, more than 30%, due to lack of sufficient information about the sources and maturity of the data. So the specific case study of our data is computational science, thinking about astrophysics, chemistry, climate and weather prediction, genomic, molecular biology, quantum physics, material science, and so on. So why software engineering for computational science? Because such software could have a widespread social and practical impact. By adopting software engineering practices, computational science researchers can prioritizing on the core science modeling, making the scientific result more credible and reproducible. SE practices should be evaluated for more than software from just standard tech giant. Finally, computational software can be used as a stress test for current SE practices. So let's start with the standard defect prediction pipeline on the commit level. So let's start with bug fixing labeling, and then bug inducing tracing, metric collection, data preprocessing, and prediction. So we're mostly focusing for this is bug fixing labeling and the data mining aspect of the pipeline. To simplify, we're gonna say the bug fixing labeling and bug inducing tracing as buggy labeling. So the standard method is keyword labeling. What is keyword labeling? So let's start with the commit messages, and we trying to identify this commit is bug fixing or not bug fixing. Why? By checking the corrective keyword in there, which is bug, fix, wrong, problem, fail, patch, to label it. However, this method in a very ad hoc way can be problematic for other domains, not software engineering. As you can see here, some of our example where the keyword method is going wrong in the middle of the column, and we can see that our proposed method can fix this right here, which is EMBLEM. So why is the labeling? If the gradual label is wrong, then we would have poor bug prediction. Then the pattern learning from the analysis is also not accurate, and the conclusion derived from the analysis is not meaningful. Therefore, we're proposing incorporating expert domain knowledge plus automation AI, which is our EMBLEM framework. It's human plus AI data route through labeling, and it is adapted to software quality assurance in computational science domain, hence this work. So we're gonna talk about our active learning framework for EMBLEM. Starting with on unlabeled commit messages, we sample a few random ones for our human expert to label them as buggy or not buggy, and then we fed that into our machine learning model to train update on both unlabeled commit and labeled one to only fetch out the more informational one for the human expert to efficiently label them. This is motivated by automated quantitative analysis should always include human qualitative analysis. Moreover, fully human manual can be too costly, and fully automatic method can perform poorly. Then we talk about our data mining method. Now we're talking about the data mining pipeline aspect. So we're using FAST-FRUGAL tree, which is proposed by Philip 2016 and be applied for software engineering by Chen in 2018 FSE. This is a binary tree decision. Define numeric at median batch rank determined by predicate goal. The max depth is 4. It's an example type with 2 to the power of d trees, so 16 trees at the most. This is effective because tuning through discretizing range based on the predicate goal will have the time try to avoid the target class when it select a leaf node that exists to null or false. And also again, it's an example model optimization, kind of similar to random forest. This is an example on an FFT tree model. So our empirical study method gonna compare two data mining method, FFT versus the standard SE1, along with the labeling method of keyword and also EMBLEM are proposing. So we start with the 678 project from Computational Science code. We're using a sanity check by Aragua 2018 to sample that to 59 project. We're picking sample project that cover a range of languages. And then these are some statistics for this project with a median of commit percentage is 23%. So our pipeline is very simple on release level, where we apply whatever we were mentioning on release I, and then we apply the predictor to the release I+1. So these are the independent variable for this 9 project, which is language agnostic to simplify it down across in all the languages project that we have. The goal is G-score, which is harmonic mean of recall for so long, and P of 20, which is really a real code to find most of the bug. So let's start with the RQ question for this study. RQ1 is how close is standard labeling method to human labeling, assuming that human labeling is the ground truth. So from our result of recall and false alarm rate, EMBLEM always doing better than keyword. So the answer is not close at all. The standard labeling method generates best defect predictor for computational science software. Let's start with comparing between traditional and FFT on EMBLEM label data, because as advised from our RQ1 result. For traditional machine learning method, it's a superfective machine, random forest, logistic regression on smoked, which is used to handle imbalanced class data. As our result showing, FFT on EMBLEM label data won out 6 out of 9 project for G-score. Again, it's also won 6 out of 9 project for P of 20. We are observing the similar trend when comparing FFT on keyword label data versus EMBLEM label data. So the answer to that question is no. So our next question is how much effort is saved by EMBLEM? Before we answering this question, we're making this assumption. The use of crowdsourcing via mechanical Turk. Second, our crowdsourcer are being paid at least minimum wage $8.25 in North Carolina. We assign 2 reader per issue report and accurate of 50% of crowd worker, where quality control questions are used to identify and prune ineffective crowd worker. And our university take a 50% overhead tax on grant. So let's start with the time cost model. We can see that EMBLEM at the end save around 8 times of the in terms of time for labeling. And in terms of money, EMBLEM also save 8 times compared to the manual labeling method. So the answer is that EMBLEM save almost 8 times of effort compared to the manual labeling. So the contribution here is that this is demonstrating how standard method might not be applicable to other domains. Second, this is the first to incorporate human plus AI to labeling data, and we see many promising directions from here. Third, we have been applying a broad range of AI tools for labeling. And four, even when starting with zero prior knowledge, this labeling method let us build useful model after inspecting only a small portion of the commit log. As I mentioned, there's a lot of future work direction starting from here. Faster method, deep learner instead of FFT, better measure collection and pre-processing, more data and domain exploration, such as security vulnerability, technical depth, static warning analysis, and so on. Before concluding the talk, my name is Hui Ken Tu again, and I'm an upcoming intern at Facebook. Moreover, as I'm about to graduating in December 2021 or May 2020 as the latest, I'm open to suggestions, challenges, and collaborating with great researchers in the domain. So please feel free to reach out to me for questions regarding this talk or any collaboration in the future. Thank you, and we're looking forward to answering your question.
Hello again. I am here with the Hui Tu and the Zayu, And the team Menzies just joined maybe in the very last minute. Okay, the authors of Better Data Labeling with EMBLEM and how that impacts defect prediction. That is a work that has been published in the Transaction on Software Engineering. And please, we have 3 authors answering your question. Don't miss the opportunity to ask them something more about their interesting work with EMBLEM. And the author has just posted to you also the link to the preprint on archive if you want also to have a look to the paper. So normally I start with the first question, waiting for the audience to warm up. Let's go. And I will make an interested question just out of the blue. Do you think that, but who is going to answer? I don't know. Do you think that I could try to use EMBLEM also and adapt it to label tests that are flaky or non-flaky? That is a very hot topic nowadays. How could I do it? I was thinking about this while hearing your presentation.
Oh, like, wait, test like flaky test?
Yeah, flaky are tests that sometimes pass and sometimes fail in intermittent way. But don't mind, if you don't know flaky test, it was out of the blue, just.
Yeah, I think definitely you can. So it would be really similar in the sense of like I would have to like so specifically for EMBLEM, it was more on the data were in string. So like the flaky test, I'm not too familiar with the domain, but I could assume in some way you can parse it in like a string format or some sort of like understanding so that like some domain expert can look at the data and then like use that to like labeling them. So yeah, I think like as long as you have, I can transfer the format from like flaky test to like similar format as the data for input for the EMBLEM. Like I can use that for EMBLEM as well.
And more generally, we can say that we've been doing this kind of incremental human in the loop stuff. I think we're up to domain 5 or 6 now. A GitHub issue close time, defect prediction, reading papers from Google Scholar to try and find which are relevant, reading source code to find vulnerability bugs. So at some point you got to say, Gérard, you've got a word for the whole framework. You call it total recall, right? And,
Yeah.
and you're very big on its generality and across many domains.
Yeah. Yeah, it's something interesting. It's a very hot research now in testing. So, but it depends on the behavior also. So, but there is one question also from Aurora Ramirez. Interesting method, thank you. You have used the EMBLEM for a binary classification problem. Would it be applicable to multi-class problem? I feel active learning is a very interesting approach for SE, software engineering, but it's not so frequently seen. So, would it be applicable to multi-class problems?
Well, the next project in this sequence, Andre Motta just sent his paper to TSE last week. So there's a submission under review, which was walking over product lines, assessing them with a multi-goal. So yeah, we have a sequence of papers that you put them together and you say there's a general framework here for humans and AI to hold hands and work together.
And usually it is easy to kind of transform the multi-class problems to like one versus the rest as some like binary classification problem.
Andre's doing multiple continuous classes, and so but you're right. Yes, the standard SVM trick, right? You've got a binary classifier, but you make n, x and not x's. If there are no other questions, Ken, do you want to talk about your upcoming work with the semi-supervised stuff where you can reduce the labeling even more?
Yes, why not?
So my upcoming work was that it's essentially based on like a very older work from like 2015, and we found that by going on like the median of the median, well, but this is only applied to like, this is only right now we only applicable to like binary, or you can do like one versus the rest class. So if you're just like going on the median and adjusting the median range, maybe instead of doing median, you can do like 25 percentile or stuff like that. And then just do, so either like below that threshold is class 0 and above that threshold is class 1. And then you keep adjusting, but so you can adjusting that base. You can do the unsupervised way. So that's the paper that we're basing off, is unsupervised learning. But with unsupervised learning, you don't know anything about the data. So we basing off on 2% of the data, and with just 2% no. So we're testing that.
So right now you can get down to 2% of the data being labeled. In the EMBLEM case, how much were you labeling?
23.
23
on median.
Ken's got some really interesting cost models where if you ask, if you did the labeling in Mechanical Turk and you did the labeling twice so you can get kappa statistics, some of the projects that we run would in theory cost $300,000 to label with Mechanical Turk resources. Once Ken gets that down to 2% of the labeling, we're talking, numbers small enough to, buy a laptop or get the labeling done. But labeling is this landmine. Is this completely undervalued, underexplored? It's almost like we should stop everything else until we can get the labeling right.
Yeah. Especially for machine learning, right? Like, because the data is as important as the data miner.
Okay, so please, for the next project in the confederation of project team, you could consider labeling flakiness would be useful.
May I ask, do you have like the paper that you pointed about, like which paper that you thinking about, like the test flakiness?
Yes, I can send you offline. Yeah.
Sure. I'd love to see that.
Okay.
Jer, is there anything you want to talk to about your Rochester work?
Not really at this point of time.
Okay, sure. He's shy.
I mean, I actually have a bit comment on the flaky tests. So we have tried to apply some active learning to prioritize test cases. And in those works, we didn't consider flaky tests because those tests are like hard to resolve, right? You don't know whether the result is reliable.
In fact, it is.
Yeah, it is really. But something we found is that with this active learning method, one advantage that the machine learning models will have some suggestions, and it will continuously having these suggestions, which seeing when it sees the result is not consist with its prediction. So if the tests are flaky, maybe like those results will be against the prediction, but we can always like put more effort to double check those tests, right? Which their testing result is against its prediction. So maybe that's some way we can kind of put more effort on those flaky tests.
Well, just to shout out to someone else's research, Federica Saro, her last TSE paper, she had a post-processor to humans reviewing things, and she found if she built a classifier around the oracle labeling things wrong and combined that oracle with the original oracle, so she's very excited about learning how to fix bad oracles.
Time is over.